Good morning, students, and welcome to Q&A session. I'm Sunit Kumar, your physics teacher. Today we are going to cover the second session for motion. So, yesterday we had our first class for motion chapter, and we had covered up to displacement, right? So, we'll continue from that. Good morning, students. Let us start the class. The students can join in, one by one. So because we cannot delay the classes, it should start on time. So now, today we are, as I said, we are going to do the second lecture of motion. So we started with the first lecture, and we did distance and displacement in the previous lecture, where we understood what is distance, what is displacement. So I also said that we'll do some more questions on distance and displacement. So we'll start the session with those questions basically. So if you see this prerequisite, so prerequisite here for this chapter is, for today's class, is basic mathematics, distance and displacement, physical quantities, scalars and vectors. All of this we did in the previous class, right? Yes, students. So these are the prerequisites as discussed. Now, the weightage of the chapter, as I said, for motion, number of questions which come in exam, the weightage of this is 8 to 10 marks question comes in exam. And today what we are going to do is we'll start with the session with numericals on distance and displacement, then uniform and non-uniform motion, then speed, average speed, and velocity. So these are the topics we'll try and finish it today. So let us start with a question which we would do today. So this is the question based on distance and displacement, and this question is also there in NCERT. So if you see this question, students, so if you read this question, what does this question say? A farmer moves along a boundary of a square field of side 10 meter in 40 seconds. What will be the average magnitude? What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? Okay. So let us first of all, in physics, what you do when you read the question, you should always make a rough diagram of that. So what has been asked in the question, you will be able to understand better. And then you can start attempting the question. So if you see this, a farmer moves along the boundary of a square field. So let's say this is the square field, right? The square field is, so this is A, B, C, and D. So this is the square field. Now, the question says this is of side 10 meters. So each of these side of this square is 10 meter, right? And he moves along the boundary of this square field of side 10 meter in 40 seconds. So he 40 seconds to start from A, he goes to A to B, B to C, C to D, and D to A. So during this whole complete one cycle, he takes 40 seconds. Okay. So 40 seconds to complete one round. Okay. Now, the question is, what will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? So his initial position is A. So after 2 minutes 20 seconds, what is the final position? Let us find out that. So total time. So total time is equal to 2 minutes 20 seconds. We need to convert this into seconds first. So 2 minutes is 2 into 60, 120 seconds plus 20. So in seconds, it will be 2 into 60 plus 20. That is 140 seconds, right? Now in 140 seconds, it takes 40 seconds to complete one round. So number of rounds if you want to calculate here. So total time is 140 and it takes 40 seconds to complete one round. So this will give you total number of round which he has completed. So when you cancel this, you will have 3.5 rounds. Okay, so 3.5 means 3 complete rounds and 0.5 means half of that. So A, B, C, D, because it is a square, half of that means the final position is C. So the farmer, he completes 3 rounds, right? He will complete 3 rounds and then finally, after 3 rounds, he'll go half round more and he'll reach at C. So this C is your final position and A was this initial position. Now you have to find the displacement here. So what you do, the shortest distance between initial and final position. So this is your displacement, AC. So if we have to find the displacement, so displacement.
क्या बता रहे कुछ समझ में नहीं आ
रहा। Did you not understand? Anyone who has a problem, I'll be able to explain you again. Lakshya. Yeah. So see what I was trying to, I'll again explain it. Maybe someone has joined later. So yesterday we were doing this chapter motion and we started with distance and displacement. So in displacement, what we know is that shortest distance between initial and final position is displacement. So the question says, in this question, what it says is a farmer moves along the boundary of a square of side 10 meter in 40 seconds. That means he covers this one complete round in 40 seconds. The side of the square is 10 meter, right? So now in 40 seconds, when he covers this one complete round, where will he be finally after 2 minutes 20 seconds? We are trying to find that. 2 minutes 20 seconds gives you total of 140 seconds of time. So once you get the total time 140 seconds, so because he completes one round in 40 seconds, next round he will complete in 80 seconds and third round in 120 seconds. Then the time remaining is 20 seconds. In 20 seconds, he will be able to cover half of the round. So he will be able to reach from A to C, right? So now in this case, the displacement is AC, right? The distance would be 3 rounds and then half of that. But displacement, we have to calculate the displacement in this question. The displacement will be A to C. This is equal to AC. And what will be AC equal to? This is equal to, by Pythagoras theorem, we can say that this is AB square plus of BC square. So AB square plus BC square, if you calculate this, this is square root of 10 square plus 10 square, that is 10 root 2. So 10 root 2 is the net displacement, 10 root 2 meter. Is it clear to everyone, students? Lakshay, could you understand this? If you have not understood, I'll repeat it again. Okay. Let's go to the next question, students. Now, before we go to the next question, let us understand this difference between distance and displacement. So we studied in the previous class, what is distance? Distance is the actual path length covered by the object. And what is displacement? Displacement is the shortest distance measured from the initial to the final position of an object. So this is the basic definition. So first difference is the difference which lies in the definition itself. So you can get the difference from the definition itself. So what definition says is that distance is the actual path length. And what is displacement? It is the shortest distance measured from initial to final position. This is displacement. So first difference is in terms of the definition itself. Now, second difference, distance is a scalar quantity. What is a scalar quantity? We studied in the previous class. Scalar quantity is one which has only magnitude, right? For example, I say that distance is 10 meter. So 10 meter is the magnitude which tells how much distance, right? And displacement is a vector quantity. Vector quantity will have magnitude as well as direction. So when I say the body has moved 10 meter towards north, so we are specifying direction also here. So direction is towards north, right? So it is a vector quantity. Displacement is a vector quantity where we also mention the direction. When we only mention the magnitude, that is distance. Okay. Third is distance is always positive. Whenever a body is in motion, distance, there will be some amount of distance traveled when the body is in motion. It would have gone from one point to other. So that distance, the actual path length which you will calculate, that will always be positive. But displacement can be positive, can be negative, or even zero. So how will it be positive, negative, and zero? Let us understand by an example. Let's say you have the initial point as A and the final point as B. If the body is moving from A to B, then we say that, and let's say it has moved a distance of 10 meter, then displacement will be plus 10 meter, because we are considering the right side as positive, the right side direction as positive. Now, if the body again moves back from B to A, then in that case, the displacement will become minus 10 meter. So A to B is plus 10 meter, and B to A, because the direction is opposite, it will become minus 10 meter. So it can be positive, it can be negative. And when I say the body has gone from A to B and then back to A, in this case, the displacement is equal to 0. Why? Because the body initial position and final position becomes the same. Body has gone from A to B and then has returned back to A. So when initial and final position is same, what will be the shortest distance? Shortest distance will be 0. So that's why here the displacement becomes 0. Is the third point clear to everyone, students? Is the third point clear to everyone?
Yes,
Okay.
sir.
Thank you, Subhranshu. So now the fourth point, distance is always greater than or equal to displacement. What does this mean? We saw an example yesterday that if a body moves from A to B, it can either go in a curved path or it can go straight, right? So the shortest distance is this straight line path from A to B, right? But the path which A takes to go from A to B, the body takes to go from A to B, can be any path, right? So all of these paths which a body takes to go from A to B, right? That will always, the path length will always be greater than the shortest distance. And that's why distance is always greater and equal to displacement. And displacement, on the other hand, will always be less than equal to distance. This is the same thing. Only thing is that it has been written in an opposite way. So since distance is always greater and equal to displacement, displacement will always be less than equal to distance. Is it clear, students? All the four difference between distance and displacement, is it clear? And if it is clear, then please note it down in your notebook, because this is a very important question which is being generally asked in exams. What is the difference between distance and displacement? Or they'll ask you write 2 points of difference between distance and displacement, or 3 points of difference. Okay?
Sir,
Yes.
can you please explain scalar and vector quantity?
Yeah, I'll explain scalar and vector quantities. So as I said in the previous class, what I'll do, I'll just rub this So did you attend the previous class, last class? I think.
Yes, sir.
No. Okay. So I'll tell you again. So there are physical quantities. You know what physical quantities are? Right? Any quantity which can be measured, right? Any quantity which is measurable are called physical quantities. Now there are two types of physical quantities. One is scalar and other is vector. Now scalar quantities are those which has only magnitude, right? And vector quantities are those which has magnitude and a direction. So for example, if we take few example, so scalar quantities, first example is mass. Now, when you mention mass of some object, let's say I say that what is the mass of this object, which is there in my hand. Let's say the mass is 200 grams, right? So when I mention the mass as 200 grams, I am only mentioning the magnitude. Magnitude means how much mass, right? Magnitude means how much mass. So in that case here, 200 gram is the magnitude of the mass. You don't need to specify the direction. Will you say that 200 gram towards north or west or towards right, east? No, you will not say all of that. So because to specify the mass, you don't need direction there. You only need magnitude there. That's why mass is an example of scalar quantity. Similarly, another example, if you see, is time, right? Now, again, time, if I say it is 2 seconds. So 2 seconds, here 2 seconds gives you the magnitude, right? Second is the unit and 2 is the number, magnitude. So this is only magnitude here. So mass, time, distance, these are all scalar quantities. Now, if I talk about vector quantities, for example, if I take force. So when I mention force, what will I say? I am applying a force in some direction, right? If I say only 2 Newton, it doesn't mean anything. Why? Because 2 Newton can be towards right, it can be towards left, it can be downwards, it can be upwards, in any direction it can be. So to specify what force we are applying, we will always have to tell the direction as well. So 2 Newton towards right. So I am pushing a body with a magnitude of 2 Newton towards right. So 2 Newton is the magnitude and towards right is the direction. So this is an example, force is an example of a vector quantity. Similarly, another example of vector quantity is displacement. So as I said, when I say that displacement is a vector quantity, that's why we say that displacement can be positive, negative, both. Because if I take one direction as positive, the opposite direction will be negative. If I take right as positive, left will be negative. Right? So displacement is another example of vector quantity. Similarly, velocity is an example of vector quantity. Acceleration is an example of vector quantity. All of these we are going to study, in coming, chapter. Now, is it clear what is scalar and vector quantities? Himanshu? Okay, thank you, Himanshu. So let us move to the next slide, students. I hope you have written all of this which is there in this slide. Now let's come to another question, right? What is this question? A body is moving along a circular path of radius r. Let's say a body moves in a circular path of radius r. The radius of this is r, right? As I said, whenever you have a numerical in physics, you should always draw a diagram. Once you draw the diagram, you will be clear what is being asked in the question. So a body is moving along a circular path of radius r. What will be the distance traveled and displacement of the body when it completes half a revolution? Let's say the body starts from this point A. This is your starting point. And when it covers half the revolution, it will reach this point B, which is diametrically opposite point. Is it clear? Now, if you have to find the distance, what is going to be the distance? The distance is going to be along the circumference, that is, half of the circumference of this circle. Now, distance will be equal to 2 pi r divided by 2, because 2 pi r is the complete circumference. 2 pi r divided by 2. So 2 gets cancelled. Distance is equal to pi r. Now, if we have to find the displacement, so displacement is equal to, now shortest distance between initial and final position. So this is the shortest distance between initial and final position. It starts from A and goes up to B. This is the shortest distance, and the shortest distance is equal to the diameter, which is equal to 2r. So displacement becomes 2r. So distance is pi r and displacement is 2r. Is it clear? Is this question clear to everyone? Okay, Kavin. Good. So let's go to the next question, students. I hope you have written down this question. Now, what is this next question? I'll give you a minute to, attempt this question. Try and attempt it on your own, and then I'll tell you how to solve this. So I'll explain the question once, okay? So it becomes easier for you to attempt the question. What is the question saying? A man travels a distance of 1.5 meter towards east, then 2 meter towards south, and finally 4.5 meter towards east. What is the total distance traveled and what is the resultant displacement? So let's make a rough diagram. As I said, first step is to understand the question and make a rough diagram of the understanding which we have. So man travels a distance of 1.5 meter towards east. So let's say the man starts from this position A. He goes 1.5 meter towards east to some point B, right? East is this direction, right? I hope you understand the directions, right? So this is your east, this is west, this is north, and this is south, right? So 1.5 meter towards east, then 2 meter towards south. So let's say he has come down to this point C, and distance traveled is 2 meter here towards south. Okay. Now, finally 4.5 meter towards east. So finally he again turns and goes 4.5 meter towards east, and he reaches the point D. So this is your final position D. Initial position was A, right? Now, when you have been asked total distance traveled is easy to find. What will be the total distance traveled? Who is going to answer? Yes, Himanshu, it is 8 meter. Good. So if I have to find the total distance traveled, so total distance will be equal to the length of the actual path AB plus BC plus CD. Now AB is equal to 1.5 meter, BC is 2, and CD is 4.5. So 1.5 plus 4.5 is going to give you 6, and 6 plus 2 is equal to 8 meter. Now we have to find displacement. Who is going to tell me how to find displacement? Now this is the most important part here. Distance was easy to calculate. We had to just sum all these distances. How will you find displacement? Okay. So what is displacement? Shortest distance between initial and final position. Students, you need to participate also. Once you participate, you will start enjoying. Otherwise, it will be a monotonous one-way lecture. I don't want that to happen, right? So what will happen? Even if you answer wrong, nothing is there to lose. At least you will, I'll tell you what is the right answer anyways, and I am not going to judge you anywhere, right? Okay. So what we are going to do, we'll join A to D. That is the shortest distance between A and D. This is the shortest distance between A and D, students, right? Now the challenge is how to find AD. Is there a way to find AD? Yes. What we'll do, we will complete this right angle triangle by extending this. Once we have completed this right angle triangle, this is 90 degree. Okay. Now this is 90 degree, means these are perpendicular, right? And we know that since this BC is equal to 2 meter, this will also be, let's say I mention this as E. This AE will also be equal to 2 meter. Now what is the length of E to D? This was C to D is 4.5, and because AB is 1.5, EC will also be equal to 1.5. Right? So this is 1.5. Now, if we have to find the distance between ED, this is 4.5 plus 1.5. This will be equal to 6 meter. Is this clear? Till here, is it clear? Now you would have got an idea how to find it. So we know the base of the triangle, right angle triangle. We know the perpendicular of the right angle triangle. How to find the hypotenuse? That is by Pythagoras theorem. So we have to find the shortest distance AD. This will be calculated by Pythagoras theorem. That is root under AE square plus ED square. Okay. Now what is AE square? Root under AE square is 2 square plus of ED square, that is 6 square. So this is 4 plus 36, which is equal to root 40. Okay. Now if we, further simplify this, we know that what is root 40? It is 2 into 2 into 2 into 5. So when you take the pair of 2 outside the, square root sign, this will be equal to 2 root 10, right? This is equal to 2 root 10 meter. So 2 root 10 meter is the net displacement. Is it clear? Is it clear, students? Everyone, is it clear to everyone? Yeah, please tell Kavin, what doubt do you have? Okay, root of 40. I'll do it here separately. So root of 40 can be written as 2 into 2. I'll prime factorize it. So 2 into 2 into 2 into 5. Now we know that this 2 into 2 is in pair. When you take a prime factor which is in pair outside the square root, this will become 2 will come outside, and then you will have 2 into 5 inside, which is 2 root 10. Is it clear now? Okay. Please note it down. Everyone, please note it down. Okay. Have you noted it down? Shall I rub this? Shall I rub this, students? Okay. So let's go to the next question, student. Oh, Laksh, I have rubbed it. Let me see if I can bring it. Okay, next question, I'll explain it. So this we have already done it. Now the next question. So the question, if I'll just read it out and explain it to you. A body travels a distance of 3 kilometers towards east, then 4 kilometers towards north. So the body travels a distance of 3 kilometers towards east. So I'll draw the rough diagram here. So body starts from this position and moves 3 kilometers towards east and reaches this point B. And then 4 kilometers towards north. Okay. So I'll just make another diagram. I'll draw it here. So body goes 3 kilometers towards east from A to B. And then 4 kilometers towards north. So let's say the body has gone from B to C. And this is 4 kilometers towards north. Now and finally 9 kilometers towards east. So let's say it has reached this point D. And this total distance is 9 kilometers. Right? Now, what is the total distance traveled? So total distance is easy to calculate. Okay. So here, total distance will be equal to 3 plus 4 plus 9. So 9 plus 4 is 13 plus 3 is 16. 16 kilometer. Okay. Now, if we have to find displacement, what we are going to do, we are going to join A to D. This is your displacement. Right. Now, in this question, we again will complete the right angle triangle here. So when you complete this right angle triangle, okay, so you already have AB as 3 kilometers. Let's say this point is E. BE will be equal to CD, that is equal to 9 kilometers, and DE will be equal to BC, which is 4 kilometers. So total length from A to E is going to be 9 plus 3, that is 12 kilometers. So the displacement here is equal to AD, which is square root of AE square plus DE square. So which is square root of 12 square plus 4 square. Right? So 12 square is 144 and 4 square is 16. So 144 plus 16, if you calculate, this is root under 160. Now, as I discussed just now, that if you have to calculate root under 160, what are you going to do is you can write it as 4 into 4 into 10. 4 into 4 is 16 and then into 10. So this is in pair. You can take 1 4 outside. This will be equal to 4 root 10. So this becomes equal to 4 root 10 kilometer. So this is your displacement. Now, is it clear? Laksh,
Yes,
is
sir.
it? Laksh, is it clear? Because you were writing that and I rubbed that. So is it clear now? It is similar to question asked in the previous. The previous question was similar to this. Okay, Laksh. Good. Thank you. So you can note this down, the question and the solution as well. Okay. I would like to announce one more thing, students. So as I said in the orientation that you will have a proficiency diagnostic test on our platform on Friday. So what you need to do, students, is there is a Google form where you need to fill the form with the details which is required to create a login on our platform, right? So whatever information is required, for example, your email ID, your mobile number, your name, your school grade, all of this, please fill it there once more so that we can create your login IDs and password on our platform. So once that login ID and password is created on the platform, we can start practicing on the platform as well. So Friday, you will have a diagnostic test, which will tell you that it is not to, judge you that how much you know and how much you don't know. It is just to have an analysis of what are your strength areas, opportunity areas, so that we can focus on your opportunity, hurdle and weaknesses areas and bring them to the strength areas during this summer course, right? That is the whole idea of this summer course, so that once you go back to school after the summer course is over, you are, at par and above par than whatever your colleagues are. Is it clear? So please fill that form. Okay. So have you understood this concept? Shall I move ahead? Now, there are two types of motion. One is uniform motion and other is non-uniform motion. Now, what is uniform motion? Uniform motion is the motion in which the object covers equal distances in equal interval of time is called uniform motion. What is non-uniform motion? So for example, this, seconds hand covers equal distance. Let's say it has to cover one complete round. It will always do that in 60 seconds, right? So 60 seconds is equal to 1 minute. So, it covers equal distance in equal interval of time. That's why we say that this second hand would be moving with is an example of uniform motion. Now, second, non-uniform motion. The definition of non-uniform motion is that the motion in which the object covers unequal distances in equal interval of time, right? So let's say every second, if you see, first second the body moved 2 meters, the second it moved 4 meters. Then again, third second it moved 1 meter. So here the body is moving unequal distances in equal interval of time. Interval of time is fixed, 1 second. But every second the body is moving unequal distance. So in that case, we say that body is in non-uniform motion. Is it clear the difference between uniform motion and non-uniform motion? So example is the bird flying covers unequal distances in equal interval of time, right? In general, when we are moving in a traffic, our car would be moving unequal distance in equal interval of time. So all of these are examples of non-uniform motion. Is it clear? Okay, students. So students, we'll cover the rest of the part, that is, average speed. So we'll cover average speed and average velocity, speed, velocity, what is speed, what is velocity, all of this in our next class, students. So thank you for joining in today. So be disciplined, keep on joining in every class so that, your learning keeps on happening without any interruption. Thank you, students. Thanks for joining in. Bye and take care.